We can assign probabilities either empirically or theoretically. If we assign probabilities empirically, that means from our knowledge of numerous similar past events. If we assign probabilities theoretically, that means we do that from our understanding of the phenomenon and the symmetries in the problem. In the case of the six-sided fair die, each side has the same chance of turning up, and so we know that for each of the six values, 1 through 6, each has a probability of 1/6. So if a random phenomenon has k equal likely possible outcomes, then for each random outcome has probability of 1 over k. For any event A, the probability of A is the count of the outcomes in event A divided by the outcomes in the sample space. So again, for the case of the six-sided fair die, we know that the sample space, capital S, is equal to 1, 2, 3, 4, 5, and 6. Now, as an example, let's find the probability of an odd number turning up when we roll a fair six-sided die. So the probability of an odd number, that's our event, and we could define that as event A, very generic here, is equal to the count of the outcomes in A. So we have three odd numbers, 1, 3, and 5. So that's 3 divided by the count of outcomes in the sample space. We have 6 numbers, so 3 over 6. And if we reduce that, that's 1/2. For this example, suppose you toss 2 dice. What is the probability of the outcome summing to 5? The sample space is shown here, and we can see that there are 36 possible outcomes. We start with a 1 on the first die and a 1 on the second die, a 2 on the first die, 2 on the second die. So there's a lot of different outcomes, right, as we go through these. There's 36 outcomes, and all of them are equally likely to occur since we're dealing with a fair die. And so the probability of each of these 36 outcomes is 1 over 36. So let's calculate the probability that the roll of 2 die sums to 5. To calculate this probability, we need to identify all the simple events in the sample space here, where the sum of the die is 5. And so here we have one simple event where that's the case. We have a 4 on the first die and a 1 on the second die. We also have another simple event, 1 on the first die, 4 on the second die. So that fits the definition. 3 on the first die, and a 2 on the second die, and so forth. So there's 4 outcomes out of the 36 where the die summed up to 5. So that's our probability. Here's some Venn diagrams showing various events. The insides of the rectangle represent the entire sample space. The circles represent the events. So here we see event A is in blue. So this blue circle represents event A. For part B, the event B is shaded. This represents the event B. The intersection of A and B are the simple events that belong to both A and B, written A intersection B. This is the area on the Venn diagram where they share in common, or where there's this overlap. The event A union B is the entire shaded area. The union of A and B are simple events that belong to either A or B, or both. This is written as A union B. And so this picture represents the simple events that belong to A or B, or both.